Gary, you are a reactor engineer at Oaklow. What does being a reactor engineer mean?
Yeah, so being a React engineer, I'll first start by saying it's a really fun and fulfilling role for me. I primarily focus on the aspect of neutronics and core design. And so that usually entails a lot of Monte Carlo simulations, as well as seeing what challenges the design may encounter and trying to anticipate them and present solutions so that we have a plan for settling them over the course of operation. And this usually includes things like, reactivity control systems, specifically from the perspective of a neutronics focused engineer.
And you did a really good job describing it. I love it. And you actually went to MIT for nuclear engineering.
Yep.
What inspired you to get into nuclear engineering?
Yeah, it's a pretty fun story too, because it actually started in high school in my junior year, where actually prior to that, I was interested in being an aeronautical engineer. But by the time I got into AP chemistry and we started talking about nuclear chem, that's where we discovered the splitting of the atom and seeing how energy dense that was in comparison to like the breaking of a chemical bond. That was really fascinating to me, I think. And it started with there, and with my combination with my interest in physics, I sort of just said, you know what, I'm going to pursue this path. And like that's what led me to looking for different schools that focused in nuclear, and seeing that MIT was one of the best, arguably the best. I said I had to go there. And so by the time I got there, it was only then that I discovered things like, climate change and like environmentalism, and seeing that nuclear had a strong impact in making that better and making the world a better place for us to live in. It really solidified my focus and like made me really want to go down this path.
Thank you. You may have convinced a few people to get into nuclear engineering. And
I hope so.
well, thank you again for your time. That was great. You are a reactor engineer at Oaklow. Do you mind telling us what your role entails?
Yeah, I mean, one of the fun things about working for Oaklow, which is a startup, is you get to do a lot of different things. You kind of get to pick up and take responsibility for whatever task needs to happen next. So I get to do a lot of different things. I am on the thermal engineering team. And so that means I help build models of how we transport heat in and around and out of the reactor designs. And to do that, I do a lot of coding. I also am somebody who does the environmental report and does the environmental analysis with my background in environmental studies. That is something I find very rewarding because I get to quantify and research how the Aurora reactor compares with other forms of power generation. So it's something where it really shows, man, like our systems are so much better for the environment. They don't use as much land, they don't use as much water, and they don't produce any emissions. And so those are some of the things I do at Oaklow. Changes every day.
Were you already interested in some aspects of engineering in high school?
Yeah, I had a weird background a little bit because I didn't go straight into engineering after high school, but I always was strongest in math and science and loved physics, and I took welding in high school, so I always liked building stuff. But I first went into environmental studies for my degree because I cared about the environment and wanted to figure out some way to help in dealing with climate change. And as I learned more about the problems, I realized this technology could be a huge benefit to the environment. And so that's why I went back to engineering, and it's so much fun. And it's also something that, I definitely was drawn to throughout my life. And I'm glad that I've come back to it.
It's really fascinating that you can kind of trace back to high school or maybe even earlier some aspects of engineering that you were already drawn to without even knowing that down the road that was going to be something that you start your career in. So thanks, Emma. Pat, you are the Director of Thermal Engineering at Oaklow. Do you mind sharing a little bit of details on what your role entails?
On a very high level, with kind of I guess one of my favorite quotes, which came from a good friend and one of our engineers. He used to say, what we do is we put a bunch of metals together and they get hot. And so kind of breaking that down a little bit, our reactor uses metal fuel and a bunch of other different metals to generate heat through fission. So kind of when you put all those together in the right way, you generate heat. My job is to work with our engineering team to design the systems to turn that heat into something people want. Most of the time that's electricity. That's something everyone wants. And so to make that, you have to take that heat from the fuel and convert it into something useful. So normally that requires, spinning a turbine or something similar. And then you can kind of harness the powers of electricity and magnetism to make electricity. So what's really cool about that is even beyond electricity, there are a lot of different things you can do with that heat to kind of give people things that they want, beyond electricity. So I grew up in Michigan. I grew up swimming pretty much year round. And so about 9 or 10 months out of the year, that meant we were swimming inside. And for, 6 of those months, it was pretty cold outside. So heating up a swimming pool, that takes a lot of energy. And in a lot of places where electricity isn't, or heat isn't available cheaply or reliably, people just don't have that kind of luxury to like have a heated swimming pool year round. So what we can do beyond generating electricity to power people's homes and businesses and whatnot, we can also use that heat to heat up a swimming pool. You can heat up a greenhouse, for instance, in the Arctic. So you can get fresh produce year round, things like that are just different ways to make people's lives better just from, converting this heat or taking this heat from fission and turning it into something useful. On kind of more of a day-to-day level, my job is doing a lot of reading about how these sorts of systems have been designed in the past. It's a lot of writing code to model these systems and how they'll perform, a lot of reading like textbooks to know how to model them, and then just working with our engineering team to make sure we're all kind of on the same page. We're all designing systems that can talk to each other in the right way. Kind of if one system expects that the other system is going to behave in a certain way, we need to make sure everyone is on the same page with all of that. What's really cool is we just have so much flexibility to design systems that will be reliable, robust, and cheap, which means ultimately we can provide, reliable and cheap electricity and heat for people who need it.
I love the way that you summarized it all. You kind of went into some technical stuff that you do, but you also brought it back to the bigger picture, which is probably something that it's really powerful and motivate you every day to do what you do. So when did you become interested in engineering? Were you drawn to it from a really young age, at least some aspects of it, and then it led you to doing what you do now?
Yeah, so this will be kind of I would say a cop-out answer, but I've known I was going to be an engineer for pretty much as long as I can remember, really. Both of my parents are very technical. My mom's a physician and my dad's a civil engineer. And then 2 of my older siblings are engineers as well. So I think this was definitely the expectation or kind of what I planned to do growing up. I think pretty much all the kind of from a very young age, I've just always had kind of a brain that's really geared for math and science. I grew up like absolutely loving sports. My mom used to say that my brain was like half sports statistics and half everything else. So that was kind of one side of things. And then, my mom really just pushed me to always be kind of thinking in a very like math and kind of numerical and quantitative way. There's one story that I love bringing up. We all kind of have a sweet tooth in our family. My mom will always have cookies like ready. She'll always have like butter laying out on the counter. So she's always, ready to make cookies in case any of her kids are hungry for them. And growing up, we used to always make the Nestle Toll House chocolate chip cookie recipe, just on, the back of the bag of chocolate chips. And what's funny is, from, I don't know, when I was like 8 years old, my mom would have us helping in the kitchen to bake the cookies, getting the sugar, the flour, all the different ingredients. And at that age, there was no way we were actually helping. We were just definitely a distraction. We were slowing things down. But my mom would, make the most of this. And so instead of making a single batch of cookies or a double batch, she would make like a 5/8 batch. And so she would ask us, all right, we have, one batch says you need 2/3 of a cup of brown sugar. How much is 5/8 of a batch? And so, this would just be like I never thought of it because as like difficult or, you know, a challenge that she was giving us, because the end product was me eating chocolate chip cookies. But it was just a good way to kind of get us like kind of thinking that way. My mom is a neonatologist, so she takes care of premature babies. So she knows pretty much everything there is to know about like child development and kind of all of the benefits and you know, all of the different things you should be doing to raise children to get them to be kind of maximize their potential in a lot of ways. And so she definitely took those lessons to heart with all of us.
I love that story. Thank you for sharing. It's really sweet.
Yeah,
and
of course.
And so you were exposed to a lot of that, like math and a lot of different aspects of engineering at a young age. That's really cool. And I can't wait to actually show this to my nephew. I think he'll be very interested in learning more after hearing from you.
Yeah. Yeah, absolutely.